Hey everybody, I needed a fourth video to clean up the rest of this chapter, and I wanted to go ahead and talk about a couple of things in remaining from chapter 2 that need to be discussed, and that is arithmetic operators. So arithmetic operators are used in programming to represent addition, subtraction, division, multiplication, exponentiation, and remainder. And so we get addition, subtraction easy, but what I want you to note is that we also need to do or think about mathematical operations in a particular order. So we have parentheses, which trumps everything else. It's above everything else. So if we have a mathematical expression that we need to make sure is done first, we would put that within parentheses. Then we have multiplication, division, and then we would have addition, subtraction. It goes in that order. Now multiplication, division, they're on the same level. So if the division is before the multiplication in the expression, it still would happen before the multiplication. And then addition, subtraction is the same thing. Subtraction and addition are on the same level. Whichever one is first would be done first. So that is mathematical order of operations. Now there's a mathematical operator that I want you to know about in case you've never heard of it before, and it is in chapter 3. It's called modulo. Okay, and modulo, the purpose of that is to capture a remainder. Okay, also it will be called modulus. So here's how this works. So we've got the division here of 70, excuse me. We've got the division of 76 divided by 12, which isn't clean because 72 times, or 12 times 6 is 72, but that leaves a remainder of 4. So what we want to do is capture the remainder. So let's say we have the modulus operating. We have 76% is the operating symbol, 12. What that says is take 76 divided by 12 and give me the remainder, which is 4. So the result of this calculation is 4. Okay, forget about the initial amount. We're just looking for the remainder. So there is a program that kind of shows you what this is like, and it's minutes and seconds. So if I enter an amount of seconds, what this program will do is convert it to minutes and then the remaining seconds. So I know if I enter, for example, 360 seconds, that is exactly 6 minutes because there are 60 seconds to a minute. But what happens if I enter 370 seconds? Well, I've got 10 seconds over, right? So I don't want to lose it. I want to capture it. So here's how this program looks, by the way, when you run it. Okay, I'll type in 370. 370 seconds is 6 minutes and 10 seconds. 10 seconds over. It captures it. So what this does is it gives you get seconds from the user, however many. You take that value, okay, and say, all right, however many minutes we've got is going to be seconds. And I said, what did I say? I said it is 60 seconds per minute, and I put in 370, so I've got 370 divided by 60. Now notice that this is integer division. It is not going to keep the remainder within itself. All right, so what I've got here then is I've captured the minutes. Then I'm going to do math again with modulus, and I'm going to say that 370 divided by 60 is going to yield 10 seconds. So that gives me the ability to print out seconds is 6 minutes and 10 seconds, remaining seconds. All right, what I want to do with the remainder of this video is deconstruct what is in your unit chapter 3.9, putting it all together. They give you this program. Let's take a quick look at this program. Okay, first thing I want you to notice is we've looked at comments before, that if you want to make a comment, you use double 2 slashes and on a line. But the problem is that's only good for that particular line. What if I want to have a lot of comments or several lines of comments? I can do that without having to put 2 slashes on every line by using a slash star to start it and a star slash to end it. Okay, and these are non-executable lines in our code that are used for comments. So that's pretty useful. Next thing I want to talk about a little bit more on variables. So we talked about integers a little bit. Integers are whole numbers. So if I work in a bicycle shop, how am I going to represent bicycles in my inventory? Well, I'm going to use an integer variable to hold the number of bicycles because I can't have parts of a bicycle. I sell whole bicycles, right? And so that is a perfect type of data to be represented by integers. Likewise, I cannot have, well, I could have, but let's say the sale price for a bicycle is $359.95. I need to be able to represent that figure, which I cannot do with an integer because it's not a whole number. It's got a decimal in it. So in that case, I would need to use a double. And so for our purposes here, you should know that centimeters are related to inches through a conversion. Okay, one is metric, one is not. And so what I'm doing in this program is converting whatever the user enters for centimeters to inches. Now, if you know this off the top of your head, that there are 2.54 centimeters per inch, okay, then we could just do the math down here as centimeters divided by 2.54. But that is only known to maybe the programmer. What about somebody else who's working on this code later? They're going to be working with what they could be called a magic number, because it's a magic number because it does what it's supposed to do, but I don't know what that is because the programmer before is the one that put that in there. It's better to create a constant. So whenever you see the keyword final, that means whatever is here is a constant. This doesn't change, but I should not use 2.54 in my calculation because I'm not going to know what it is. Better to use this, centimeters per inch, and I'll know exactly what that is. Same with, you know, even though almost everybody knows that there are 12 inches to a foot, we should get away from assuming and go ahead and make this a constant as well, instead of using it in the calculations below. So that is using a constant. Now, constants can also be used for other purposes that are even more powerful. For example, in Franklin County, I think the sales tax is 7.5%. What if the sales tax is risen to 7.75%? Well, any programs that have 7.5% hard-coded into the calculations would have to change that calculation everywhere it's referenced, in no matter how many hundreds or thousands of places that could be. You would never code that way. You would want to create a constant for sales tax, for example. So if that sales tax rate were to change, you only have to change it in one place, because the rest of your reference would be to sales tax in the code. So that's a powerful use of constants. So getting back into this, we have a scanner object. So note that the scanner object is called IN here. That's fine. You can call it anything you want to. We called it input before. So you might also see it as SC somewhere. That's just what they decide to call their scanner object. So the scanner object is declared here as opposed to at the class level, which we did before. It doesn't matter in this program. The only reason I wanted to put it up here before was to show you that it would be available to any of the methods in the program, not just the main method. Since this program only has a main method, it's just fine that it's declared here. You just may have been wondering that. Okay, next we're prompting the user with the print, not the print ln, because that goes to another line, but the print. Exactly how many centimeters. Notice that there's a space after the question mark and before the end of the quotation, so whenever the user types something in, it's not right against the prompt. All right, then what we're doing is we are taking our scanner object input, or in here, and making it next double. So next double is what we would use to capture a double's input. Centimeter is double, okay? Before we saw next line, which we use for string input, and we've seen next int, which we use for integer input. So next, okay, that's our input. Now we're converting and getting our results. So centimeters divided by centimeters per inch, the 2.54, is how many inches we get. Now, what we're doing, though, to work with this cleanly is we are converting whatever the math was there. Whatever the math was here, we're doing, but then we want to convert the result to an integer, and that's what where this int is coming from. So because inches is integer, we have to do that conversion. Okay, so feet is equal to inches divided by inches per foot, which we know is 12. Then we calculate our remainder, just as we did with the seconds in the other program. Okay, and so let's see how this looks. I happen to know that 33.02 centimeters will give me 1 foot 1 inch. So you see how this conversion took place with the remainder. The remainder was my inches, right? Now, the output looks a little bit different. They talk about this in your book, and instead of using print or print ln, we're using printf, which stands for print format. This is a substitution type of thing. Notice where we have percentages here. We have a percent here, here, and here. And what are we replacing these things with? We're replacing them with the variables for centimeters, feet, and remainder. And they have to be in that proper order. So, in displaying centimeters, we want to use a floating point to 2 decimal places. Okay, that's where the 2 comes in. And the floating point, remember we talked about centimeters being a double. Okay, so that's where that comes in. We would use this for a double if we want 2 decimal places. The %d we're using for feet because it's a whole number, and %d for inches because it's a whole number also. Well, inches, even though it's the variable's called remainder, it's really inches. So that is how this converts to this output. Now, I want to just take the last bit of time here to say there is a whole comprehensive deep dive into print format on various websites that you can easily pull up and see what print format function does what. But in this case, in the book, they just give you enough for you to go on. So good luck, and we'll see you later.